Crop production database. Crop production database is used to know how many hectares have been cultivated, where the cultivation has occurred, and how well the likely production of food area and production various crops can be assessed with the help of remote sensing and GIS application. Growth and yield determination. Crop growth and yield are determined by a number of factors such as the genetic potential of crop cultivar, soil with cultivation practice such as that of soil, amount of irrigation and fertilizer, and biotic stresses. However, generally for a given area, year-to-year yield variability has been mostly modeled through weather as a predictor using either empirical or crop simulation approach. Crop monitoring. The use of GIS along with RS data for crop monitoring is an established approach in all phases of the activity, namely preparatory analysis and output. In the preparatory phase, GIS is used for a stratification zonation using one or more input layers: climate, soil, physiography, crop dominance, etc. Or B. Preparing input data, weather, soils, and cultural data, which is available in different formats to a common format. In the analysis phase of GIS is mainly through operation on raster layers of NDVI or computing VI profiles within specific administrative boundaries. Summing up, the use of remote sensing technology has been rapidly expanded for the development of all sectors that also includes agriculture. The remote sensing techniques will continue to be a very important factor in the improvement of present system of the acquiring agricultural data. The remote sensing provides various platforms for agricultural survey. Satellite imagery has a unique ability to provide the actual synoptic views of large area at the time, which is not possible for conventional survey method, and also the process of data acquisition and analysis the area very fast through geographic information system as compared to the conventional methods. Mapping soil resource with remote sensing data. Soil is the heart of terrestrial ecology and is vital to our very existence. However, there is evidence to show that a majority of our soils are undergoing degradation at an unacceptable rate, with risks of jeopardizing our food security for the future generation. Spectral reflectance of soils. In many applications of remote sensing in soils, understanding the principle of spectral reflectance of soil is fundamental, and the limitation is crucial. The soil reflectance data can be acquired in the laboratory or in the field and from air outer space. In the laboratory, the soil reflectance. However, the measurements are affected by variation in viewing angle or illumination condition and darkness factor. The most important soil properties that influence the reflectance are soil moisture, content, texture, structure, and iron oxide content. These factors are interrelated, and the spectral reflectance of soil is cumulative property of combination of the specters. Soil color is mostly influenced by mineralogy, chemical composition, soil moisture, and organic matter content. It is an important parameter is allows the diagnosis of soil types and their properties. Several research observed that the visible and near-infrared region are the most suitable spectrum ranges of EM spectrum for quality type and quantitative description of soil. Particle size or soil texture refers to relative proportions of sand, salt, and clay in soil. Is another soil property that influences the spectral reflectance of soil significantly. Finally, the particle size. The soil becomes smooth and more incoming energy is reflected, and increase the particle size causes the decrease in reflectance. However, seed content of soil is considered as minor controlling. Soil minerals, fish, cleaving mineralogy, and iron oxides have significant influence. Clay minerals are rare crystalline aluminosilicate minerals, which are characterized by hydroxyl bands at 1.4 and 2.2. Carbonate response bands have been noticed. Soils with gypsic minerals have high reflectance because of the inherent reflectance properties of gypsum. Soil mapping. Satellite data from Indian remote sensing sensors are being used to generate soil map through monoscopic, non-stereoscopic, visual interpretation, and computer-assisted digital analysis approach. In visual interpretation approach, the intimate relationship between physiography of the terrain and soil occurring then exploited lithological. The computer-assisted digital analysis is essentially based on the premise that each object could be characterized as a unique spectral response pattern. The approach consists of the stages, namely training stage, classification stage, and testing and validation stage, establishing the relationship between the spectrum classes and soils occurring during studying soil profiles and augurs in the field, followed by chemical analysis in the laboratory. Land degradation. As Forward Research Institute, land degradation is the deterioration of soil, several reduced productivity of desirable plants, and declining diversity of flora and fauna because of the activities of both people and livestock. The study, published in as report titled "Remotely Sensed Data from Satellites Are Being Operationally Used to Derive Information on the Degraded Lands and Monitor them periodically in time and space domain using multitemporal." The general approach. The general approach for mapping and generating land degradation database will be as follows. Remote sensing multispectral data, preferably resources least 3 or compatible resolution, covering Kharif, August until Nov, Rabi, January until March. Zaid, land degradation. Development of classification scheme and interpretation course for multitemporal data sets. Georeferencing of multitemporal IRS LISS3 dataset to standard spatial reference framework. On-screen visual interpretation of different land degradation classes on satellite data (VSAC), following standard visual interpretation technique, adapting the finalist classification scheme and interpretation course. Statistically, at some points, file work has to be carried out by the interpreter, including soil sample collection along with the site details. The preliminarily interpret land degradation map will be penalized in the light of the growth truth data. The minimum mapping polygon size of 3 scale equivalent to 2.25. Quality check has to be performed randomly, and thematics maps are to be assessed for thematics as well as location accuracy. Digital geodatabase, well to develop it to address retrieval and storage of the different data. The land degradation database that's developed can be using a lot with various other thematic dataset like land cover, digital elevation model, climatic dataset for developing suitable reclamation plans. Thank you.